quick demo of the Game Night Buzzer. I'm powering it off of a power bank, and you can press all the buttons at the same time, and one button will win. And when it wins, it's indicated on the LCD, and the LED lights up of that particular button. It automatically resets after a few seconds, and the other buttons are locked out, and you can also reset it. It is powered by my Raspberry Pi Pico.
Hi everyone, I'm Caroline, and welcome to my Maker channel. In my last video, I built a Game Night Buzzer using this Arduino Uno connected to a Raspberry Pi 4 for a fun Jeopardy-style project to see who buzzes in first. Well, today we're replacing that with a Raspberry Pi Pico. My buttons are still the same ones I upcycled from my Google AI voice kit, and if you don't have one, I'll link to some options. Now, if you're watching this video in November 2025, I'm giving away a brand new Google AI voice kit version 1 this month. Stay tuned until the end of this video for details on how to enter. Now let's get started.
The materials you'll need for this project include your Raspberry Pi Pico with the headers. So I soldered these on myself, and I do have video on how to solder the headers if you need that. I'm using my Raspberry Pi 4. After I get this project done, I can power everything from a power bank. This is a micro USB data cable. Other things that I'll need, I'll be using this 16:2 LCD screen, and I am going to use a Piezo buzzer and a push button. This is for the reset. For the arcade buttons or for the game player buttons, I am using these arcade buttons. I'm recycling this from my Google AI voice kit version 1, and I did 3D print a little holder for the button, so it just slides in like this, and then I'm using the nut that came with it. I'm also reusing the cable from the AI kit that's got these nice spade connectors. For the final project, I will be using this 3D printed case. I will link over to this 3D printed case. And yes, we'll need lots of jumper cables for this. Male to female, male to male jumper cables with this project. We're going to start off this video by connecting our data micro USB cable to the Raspberry Pi by first holding down the boot cell button right here, and then connecting to our Raspberry Pi. Wiring for the LCD is ground to ground, VCC to VBus right here, which is the power, SDA to pin 0, and SCL to pin 1. And that will get our LCD connected. And we are starting off with our Raspberry Pi desktop, and I'm going to go ahead and open up a web browser, Chromium. And with our Pico inserted, you may see this message, removable medium is inserted. I'm going to click cancel on my GitHub page. Download the MicroPython UF2 file for your Pico from this page, and it brings you to the Raspberry Pi projects page, and you can download the correct MicroPython. I've already done that. It's in my downloads, and I'm going to open a file manager, and I'm going to click on download. And once you have that, all you have to do is just drag and drop it, drag to your Pico, which should be under file system root, and then you can start working with your Pico. Let's go over to the Raspberry menu. Under programming, we are going to open up Thonny. To set up Thonny, we are going to click on these 3 lines here. This is the menu button, and we should be able to click on Raspberry Pi Pico, and that opens up the Pico. There are 3 lines here for the menu. Click on that, you may need to refresh it. From the GitHub page, get clone, so you can copy all the files, or you can just download all the files. I'm going to do get clone, I'm going to copy, I'm going to open up a terminal, and I'm going to paste, and there we go, get clone this entire repository to our Raspberry Pi. If we go back to our file manager, under admin, we should have RPI-Pico-game-buttons. I'm naming these files 1, 2, 3, and 4 by the name of the step. First step is LCD. So let's get our LCD working here. Let's go back to Thonny, and we are going to go to that folder here, RPI Pico, and I see that LCD. I'm going to double click to open, and let's run 1-LCD by clicking the run button. And sure enough, now the LCD reads, welcome to game night. Perfect. That is the expected response. It is working properly. I'm going to hit the stop button. Next, let's move on to 2- button.
I will double click it and we'll open 2- button. And now we need to get our button connected.
To get our button connected, we need to connect ground to ground, which I've already done to this ground line I created. And we're connecting the button to GPIO 18.
Now let's run 2- button and I'll click the run button.
And now the LCD reads press the button. Let's press the button. And it says button pressed. Perfect. That's the expected result. It automatically resets after a few seconds. Next, let's connect our buzzer. So I'm connecting ground to ground, and then we are going to connect the positive lead of the buzzer to GPIO 15.
And I'm going to click stop on the button here, RPI Pico game buttons folder again, and I'm going to double click 3- buzzer, open up that file, and I want to run that on my Pico, and I'll hit the run button.
And over on my Pico, the LCD says press the button. Let's press the button. And it says button pressed. And now the buzzer makes a little noise. And it does reset after a few seconds. Very good.
Head it back over here to my Raspberry Pi desktop, 3 buzzer. I need to stop that. I'll click stop. And next I will open toggle-button.py. And I'm going to go back to my browser. Now I'd like to show you the wiring table. My GitHub page, Team 1 button is wired to GP16, but the LED, which is 2 separate leads, is going to be wired to GPIO 6. And so on and so forth for up to 6 buttons and 6 LEDs. I also want to show you my wiring diagram. I apologize, this is the worst diagram I've ever made in my entire life. And here's a better view of the arcade button blowout. The positive lead for the button is in the top right corner if your crown is facing upward, and ground is on the left for the button, and the LED have the positive on the right and the negative on the left. In the wiring diagram, that means that your button will go to GPIO 16, or ground goes to ground, and then for the LED, it goes to GPIO 6, and ground goes to ground.
And this does fold nicely into my 3D printed case. And I'm going to just close up that case. And that is how we wire up one button. And we'll follow the same suit for the rest of the buttons, but let's just do one button now.
We have opened 4-toggle buttons, and I'm going to hit run.
And over here, now the LCD screen reads ready, press a button. I will press the red button. And when I press the button, it says last press team 1. And that's to indicate button number 1. Now it does light up when I press the button and does reset automatically, and then when I press it again, it should toggle that LED inside the button. Now we're going to follow suit with the rest of our buttons and connect these up. We have now connected up all 4 buttons. We're still running the same code, which is step 4, and pressing the button just toggles the LED, and when I hit a button, it tells me which button I hit. If you press team 1, red, and then team 2 is green. It says last press, team 2, number 3, and then number 4. It's a great way for you to check your connections, and you can turn them all on and off at the same time. That way you don't have to wait for it to reset. But this is just to check to see if you have everything wired up correctly. So now I believe I have all 4 buttons wired correctly.
And back over here on my Thonny, now I have main.py. I'm going to double click and open it. And as you can see, I've got the pin designations, team 1, team 2, team 3, team 4, 5 and 6, pins 16, 17, 19, and 20, because I'm using 18 for the reset pin. LED pins are 6, 7, 8, and 9. And that's how I have it wired up. I'm going to hit the run button. Oh, and there we go.
And now if I press a button or I press several buttons at the same time, team 1 wins. Okay, so it locks out all the other buttons until you hit that reset button. And let's press another button. Team 4 wins, and it lights up. And then we can reset it, or we can just wait. Let's try another button here. Team 2 wins, and you see it's lit up. And when you let it reset, it automatically resets. Now let's hit the yellow button. That's team 3. And as you can see, all the other buttons are locked out until we reset. So you can press several buttons at the same time, and only one button is the quote-unquote winner. It's the fastest button, and that is how the code works. Now I'm going to do a little personalization here.
The way we have the team names configured, we have team 1, 2, 3, 4, and 5, and 6. Since they have colors, what I'm going to do is change it to the colors. And now I've changed it to the colors, and I want to save this onto my Raspberry Pi Pico so that it will automatically default to this code.
Gotta stop it first, and then I'm gonna hit File, Save As, and I'm going to select Raspberry Pi Pico. Now I choose the name main.py because then it tells the Pico this is gonna be my default. Now I've saved it to my Raspberry Pi Pico. I'm gonna hit Run. And then I'm gonna go back over here and hit all the buttons, and the green team wins. And it says green, and it lights up, and it locks out all the other buttons. All right, ready to go. Let's try again. Yellow wins. Yes, as you can see, everything is locked out. You can hit reset. Red wins. And that is this project. And we saved it as main.py. And what we can do now is we can unplug this, and now we can plug it into our 3D printed case. Now I'm going to connect my power bank charger to my setup here, and you can see all the buttons. So I'm just going to hit all the buttons at once. It says white wins. White is lit up here, and then I'm going to wait for it to reset, and then I'll hit another button. Green wins. Okay, perfect. And you can see all the other buttons are locked out. And to reset, you can press the reset button, and then you can hit another button, and all the other buttons are locked out. Reset, red, reset. So if you press all the buttons at once, it will choose a winner, and you can reset it at any time. But once you choose a winner, yellow, everything else gets locked out. And that is the full demo of this project, and it works right on boot with your Raspberry Pi Pico.
And there you have it, your very own Raspberry Pi Pico Game Night Buzzer with arcade buttons, an LCD screen, and custom sounds. If you missed my Arduino Uno version, I'll link to it so that you can see how the two builds compare. And if you're watching this video in November 2025, don't forget I'm giving away this discontinued Google AIY Voice Kit version 1. The Raspberry Pi 3 is not included, and this giveaway is open to US addresses only. To enter, comment below with the game you love playing on game night and fill out the entry form linked in the description. I'll announce the winner live on my channel. Thanks so much for watching. Make sure you like, subscribe, and hit that bell so you don't miss my next project. If you'd like to support my channel, a great way to do that is to purchase my book, A Woman's Guide to Winning in Tech. I'll see you next time. Bye now.